Okay, now today we will discuss about some problem based on thermal expansion. So question number 1 is, two rods, one of aluminium and the other made of steel, having initial length L1 and L2, are connected together to form a single rod of length L1 plus L2. The coefficient of linear expansion for aluminium and steel are alpha A and alpha S respectively. If the length of each rod increases by the same amount when their temperature are raised by T degrees Celsius, then find the ratio of L1 by L1 plus L2. First option is your alpha S by alpha A. Second option alpha A by alpha S. Third option alpha S by alpha A plus alpha S. And the fourth option alpha A by alpha A plus alpha S. Now see how to solve this problem. So this is the question number 1. As per the question, it is given the aluminium and steel, there are two rods. Aluminium have length let L1 given, and this have coefficient of thermal expansion your alpha A. This is aluminium. And another rod is your steel, and this having length L2, and the expansion coefficient of this alpha S, this has been made from steel. Now combined length is your, now when it is heated, so L1 dash will be your L1 1 plus alpha A into T degrees Celsius as is given. Similarly, L2 dash is equal to your L2 1 plus alpha S T degree Celsius. Now they are asking what is the ratio of L1 by L1 plus L2 when they are increasing the same amount. See, L1 by L1 plus L2. It is given these two are heated up to same temperature T degrees Celsius, then the length of each rod increases by same amount. So according to the given question here, this we have to determine. So on heating the change in the length of L1 dash here, that is equal to your change in the length of steel delta L2 dash. So change in the length. So delta L1 means here L1 dash minus L1, that is equal to your delta L2 dash means L2 dash minus L2. See here. From here we can write, see the expression, L1 dash minus L1 is equal to your L1 alpha A T, that is equal to your L2 alpha S into T. So that gives us L1 by L2 is equal to alpha S by alpha A. So this is the relation. Now this we have to find. So see from here, that can be written as 1 by 1 plus L2 by L1, which is equal to, so L2 by L1 you can write from here 1 by 1 plus L2 by L1 your alpha A by alpha S. So this is your alpha S by alpha A plus alpha S. So this is our answer. So option number 3 is the correct option. Hence the correct option your answer number 3. Question number 2. The question is this: a pendulum clock has an iron pendulum 1 meter long and the expansion coefficient of iron is given 0.00001 per degree Celsius. If the temperature rises by 10 degrees centigrade, the number of seconds the clock loses per day due to this change of temperature will be. So, first option is given 8 seconds, second option given 10 seconds, third option here 4 seconds, and the fourth option here 5 seconds. So, see here how to do. As the temperature of, as we know, time period for this is here given as L by G. As the temperature is changes, as if temperature increases, so length will increase, so time period will increase and the clock becomes slow. The clock becomes slow, so we will lose the time. The time loss given as time loss delta T can be solved by this relation, half alpha delta theta into T. So half alpha is the expansion coefficient of the material from which the pendulum has been made. Delta theta is the change in temperature. T is the time in which they are asking how much loss or gain of time. See here, half alpha value. Alpha given as 1 into 10 to the power minus 5. And temperature change is given 10 degrees Celsius. And the time they are asking in 1 day. 1 day we will convert into second. 1 day, 24 hours, 60 minutes, 60 seconds. Now we will simplify this one. 10 to the power minus 5 into 12 into 36 into 10 to the power 3. Now further we will simplify. 432 into 10 power minus 5 into 10 power 3. So this is your 4.32 second. So approximately time is your 4.3 second. So correct option we can say option number 3, which is 4 second. Question number 3. Question is this: the steel railway track is to be stopped from expanding at the joints due to temperature increases. If the area of cross section of the track is 100 centimeters square, then the elastic potential energy is stored per meter in the track due to temperature increase of 10 degrees Celsius will be, where Young's modulus is given 2×10⁻11 Newton per meter square and the coefficient of linear expansion of steel is given 1.2 into 10⁻⁻5 per degree Celsius. So first option here 288 joule, second option 144 joule, third option 28.2 joule, and the fourth option 14.4 joule. See, as we know, elastic potential energy given as, that is given a half stress into strain into volume, and further stress again can be written as half Young's modulus into strain square into volume. Now in this here they are giving us the temperature changes by 10 degrees Celsius. So this is your energy. So first we will find the strain, and volume is given, area of cross section is given, length for 1 meter they are asking. You see, strain value. As we know, L is equal to your L naught 1 plus alpha delta theta. So delta L by L naught, which is equal to your alpha into delta theta, that is called your strain. Strain is your alpha delta theta. So see here. So energy stored your half Y strain alpha delta theta square into volume, area of cross section into length L. Now substitute the value. Half Y, Young's modulus given here 2 into 10 power 11. 2 into 10 to the power 11. Alpha expansion coefficient is given 1.2 10 power minus 5. 1.2 10 power minus 5. And delta theta, change in temperature. Temperature change is given here 10 degrees Celsius. That your 10 is square. Area of cross section of the track is given 100 centimeter square. So 100 meter square, 10 power minus 4, and length is your 1 meter. Now we will simplify this. 2 and 2 cancel. 10 to the power 11 into 1.2 square. 1.44 into 10 power minus 4, 10 power minus 8. Then 10 power minus 2. Now we will simplify. 10 power minus 8 minus 2 is 11. This will be your 14.4 joule. This is the energy stored in this. So our correct option is the option number 4. So an answer is your option number 4 is the correct answer. Question number 4. Question is that on heating a liquid of coefficient of cubical expansion alpha in a container having coefficient of linear expansion is alpha by 3. The level of liquid in the container will. Option number 1 is given rise. Option number 2 is your fall. Option number 3 remain almost stationary. And fourth option here, it is difficult to say. See, in this problem here, in this question it is given this a cubical expansion of a liquid, and a cubical expansion for a liquid is your alpha given, and linear expansion of material, linear expansion of the container is alpha by 3. So cubical expansion of container is equal to 3 times linear expansion. 3 times linear expansion, then which is your, if I am substituting the value, it comes your alpha. So cubical expansion of liquid is equal to cubical expansion of material or container. So hence no change in the level of liquid. No change in the level of liquid. So our correct option is your option number 3. So an answer 3rd is the correct option. Question number 5. The coefficient of real expansion of liquid is 0.2. The coefficient of real expansion of liquid is 0.2 into 10 power minus 3 per degree Celsius. If the density at 0 degrees Celsius is 10 gram per cubic centimeter, there is density at 100 degrees Celsius. First option your 9.8 gram per cubic centimeter. Second option 98 gram per cubic centimeter. And third option is your 0.98 gram per cubic centimeter. And the fourth option is 10.2 gram per cubic centimeter. See how to do this one. As we know, on heating, mass remain your constant. So mass at any temperature, mass at 0 degree is equal to your mass at theta degrees Celsius. That remain your constant. And mass is equal to your volume into density. Volume at 0, density into 0. And that also written as volume at theta, density at theta. So density at theta by density at 0, that is equal to your volume at 0 by volume at theta. So this can be written as 1 V naught 1 plus gamma into theta. This is the relation now. So density at theta is equal to density at 0 by 1 plus gamma theta. Now substitute the value. Gamma at 0 degree is given here 0.2 10 power minus 3. Density at 0. Density at 0 given 10 gram per Celsius. 1 plus gamma value given 0.2 10 power minus 3. 0.2 10 power minus 3 and theta is given here 100 degree. Theta is 100 degree. Now we can simplify. Gram per cubic centimeter. Density at theta 10 by, this is 0 0, this you cancel, 1.02. 10 by 1.02, that will approximately, it will come your 9.8 gram per cubic centimeter. So our correct option is your option number 1. Hence option number 1 is the correct option. Question number 6. Question number 6 is this. The apparent coefficient of expansion of liquid when heated in a copper vessel is C and when heated in a silver vessel is S. If A is the linear coefficient of expansion of copper, then the linear coefficient of expansion of silver is. The first option is given C plus S minus 3A by 3. The second option here C plus 3A minus S by 3. Third option S plus 3A minus C by 3. And the fourth option C plus S plus 3A by 3. Now see how to do this problem. See. As per the question, the information given apparent coefficient of expansion of liquid when heated in copper vessel is C and silver vessel is S. See, we can write here apparent expansion of copper, apparent expansion of liquid when heated in copper is your C. So meaning of that, apparent expansion is nothing, it is the real expansion of a liquid minus real expansion of a copper. So this we can say let gamma real, this is gamma real expansion of liquid minus real expansion of copper, that is your C. This let your first equation. Similarly, it is given as apparent expansion of liquid when heated in silver vessel. That is given here S. Same thing here also. Gamma for liquid is real expansion of liquid minus real expansion of silver, which is your S. This is your second information. Now it is given the linear coefficient of expansion of copper is your A. Third information given linear. So gamma C, this is your cubical. That is equal to your 3A. This is third information given. And they are asking the linear coefficient of expansion of silver. They are asking alpha for silver. This is we have to determine. So first we will determine the gamma silver. So alpha silver is nothing. It is the gamma silver by 3. Now see, from first and second equation, we can write like that. See, from equation 1 and 2, subtract 1 minus 2. 1 minus 2, so this become your gamma silver minus gamma copper is equal to your C minus S. And now gamma silver is equal to your C minus S and plus gamma copper. And gamma copper is your 3A. And gamma silver is nothing, 3 alpha S. 3 alpha S here, C minus S plus 3A. So alpha S, linear expansion coefficient is here by 3. This is the answer. So linear expansion coefficient of silver is C minus S plus 3A by 3. So C minus S plus 3A by 3, the correct option is your option number 2. So hence, question number 7. A fixed mass of an ideal gas is maintained at constant volume. The pressure of the gas at triple point of water is P0. Then the thermodynamic temperature of the gas when pressure P is this. First option your 273.16 P by PTR. Second option your 273.16 P minus P critical pressure by TR. Third option your 273.16 T temperature by P. Fourth option 273.16 P plus P triple point by P. Now see how to do this one. See, when we are making a thermometer, so normally there are two methods of determining the or making of a thermometer. One, considering the reference point of boiling reference as a boiling point of water as well as freezing point of water 0 and 100. By considering these two reference points, we are making a thermometer. Another reference or another method is that is the now in the new thermometry, where we are considering triple point of water as a one reference point, and triple point of water is that point where all the three states of a water coexist. So on the basis of that reference point, we are making a thermometer. So with respect to that, so temperature of any object is defined as 273.16 by P and TR. TR is the PTR is the this pressure at triple point, and this in the Kelvin. So actually this is the formula, or this is the method by which we determine. So just substitute the value of pressure at triple point of water, and P is the pressure at any certain temperature which we have to determine. So just putting the value in this, then we can get answer. So our correct option is your option number 1 is the correct option. Now see the question number 8. A steel scale is correct at 0 degrees Celsius. The length of a brass tube measured by it at 40 degrees Celsius is 4.5 meter. The correct length of the tube at 0 degrees Celsius is, where linear expansion coefficient of steel is 11 into 10 power minus 6 per degree Celsius, while the linear expansion coefficient of this brass is 19 into 10 power minus 6 per degree Celsius respectively. So correct option, your option number 1 is 4.001 meter. Option number 2 is 5.001 meter. Option 3 is 4.999 meter, and option 4 is 4.501 meter. Now first of all, see how to do this one. It is given expansion coefficient of steel is alpha for steel is given 11 into 10 power minus 6 per degree Celsius, and alpha for brass is given 19 10 power minus 6 per degree Celsius, and the steel scale, it is given the steel scale give the correct reading, length of a brass tube measured by it 40 degrees Celsius here for C. We can say let this your brass tube. This is brass tube, and this has been measured from a steel scale. Steel scale, it has been measured from the steel scale. So steel scale gives a correct reading. Correct reading at 0 degree Celsius, but at 40 degrees Celsius its reading here 4.5. 40 degrees Celsius its reading is 4.5 meter. Now it means on increasing temperature, the length of the calibration your, or you can say 2 consecutive calibration length your increases. So what happened on heating, it give lesser reading as per the actual reading, but simultaneously brass is also your increases. So what we can do, true reading is equal to your scale reading, and 1 plus alpha we can say apparent, alpha apparent into delta theta. See, we want true reading. Scale reading is your 4.5. At which temperature? At temperature your delta theta, that your 40. 1 plus alpha apparent, difference of this 19 minus 11, 8 into 10 power minus 6, and temperature difference your 40. Now simplify. 4.5 1 plus 320 into 10 power minus 6. Now further we are simplifying. 4.5 1.00032. So this we can see from here that your 4.50032. So the approximate value are little bit more than 4.5. So our correct option your option number 4. Question number 9. This question based on the matrix matching. In the column 1, 4 some options are given and we have to relate with the option given in the column number 2. In the column number 1, A is option given thermal expansion, B given alpha, beta, gamma, and C given bimetallic strip, D given invar steel. While in the column number 2, P option given pendulum clock, Q option given depends on dimension, material, temperature, and R option given depends on nature of material only, as well as option number S is given balance wheel of a watch. The first thing, thermal expansion, column 1. Now in the column 1, thermal expansion. So if we are looking the options available in the column 2, so what we can say, thermal expansion depends on the change in temperature of the body as well as the initial dimension of that body. So according to the options available in the column 2, our Q option is the more appropriate option, which is depends on dimension as well as material, temperature. So we can match A with Q. Similarly, in the B option, alpha, beta and gamma. Alpha, beta, gamma is the expansion coefficient of material. Alpha is a linear expansion coefficient, beta is your surfacial, and gamma is cubical. These all absolutely depends on the nature of material. As material changes, our alpha, beta value also changes. So the most appropriate option matches with the B is your option R, depends on nature of material. So B should be the correct your R. Similarly, in the C, if we are looking bimetallic strip, the bimetallic strip here, so when we are looking our options available in that, bimetallic strip we are using in case of balance wheel of a watch. Our C option your option number S, while invar steel we are using in the pendulum clock. The C option your S, while D option your P. So as per this, our correct option your option number 1. Question number 10. Question is given as, at 0 degrees Celsius, the densities of a cork and liquid in which the cork floats are D1 and D2 respectively. The coefficient of expansion for the material of the cork and the liquid are gamma and 100 gamma respectively. If the cork sink when the temperature of the liquid is your T degrees Celsius, then the ratio of D2 by D1 is, first option your 1 plus 100 gamma T by 1 plus gamma T. The second option your 1 plus gamma T by 1 plus 100 gamma T. Third option is your 100 plus gamma T by 1 plus gamma T. Fourth option your 1 plus gamma T by 100 plus gamma T. Now see here how to do this one. First thing, density of the cork material is your D1, while the density of the liquid here D2. Density of cork is D1. Density of liquid is D2. And it is given the coefficient of expansion for material of cork. And gamma for cork is here, let gamma. And gamma for liquid here given 100 gamma. It is given. And the cork sink when the temperature of the liquid here T degrees Celsius. See, cork sink means that give us weight of cork equal to your Buoyant's force. Buoyant's force. So weight of cork and m into g, Buoyant's force v, density of liquid into g. Now this is at theta degree or T degree temperature. G does not changes. Now m, mass of the cork. Mass of the cork means volume of cork. Volume of cork and density of cork. This is equal to here. Volume of cork, density of liquid at theta. Now density of cork at theta. Density of cork at theta is equal to initial density of D1 by 1 plus gamma into T, while density of liquid initial here D2 by 1 plus 100 gamma T. Now they are asking the ratio D2 by D1. So this gives us D2 by D1. D2 by D1 is equal to your 1 plus 100 gamma T by 1 plus gamma into T. So answer is your option number 1. The question number 11. The density of liquid of coefficient of cubical expansion gamma is rho at 0 degrees Celsius. When the liquid is heated to a temperature T, the change in density will be the first option here, rho gamma T by 1 plus gamma T. The second option here, rho gamma T by 1 plus gamma T. And third option here, rho 1 plus gamma T by gamma T. And the fourth option, rho 1 plus gamma T by gamma T. So it is given the density of liquid of coefficient of cubical expansion gamma is rho at 0. Density of liquid is your rho and its cubical expansion is gamma. So they are asking change in density at temperature T. As we know, density at theta is equal to your density, initial density by 1 plus gamma into theta. So density at theta or at T is equal to your initial density at rho 1 plus gamma T. This is the density at T. So change in density. Change in density, delta rho is your rho T minus rho. So rho T is your rho by 1 plus gamma T minus rho. Simplify. you will get rho common, and this is your minus gamma T by 1 plus gamma T. The minus sign indicates density or decreases. So minus rho gamma T by 1 plus gamma T. So our correct option, your option number 1. So question number 12. If the coefficient of absolute expansion of a liquid is 7 times the coefficient of cubical expansion of the vessel, then ratio of coefficient of absolute and apparent expansion of the liquid is, first option your 1 by 7, second option your 6 by 7, third option 7 by 6, and the fourth option 7. See, it is given coefficient of absolute expansion of a liquid is 7 times the coefficient of cubical expansion of the vessel. And a liquid, gamma for liquid is 7 times gamma for container. This is given. And now we have to find the ratio of coefficient of absolute. So what we have to find? Ratio of coefficient of the coefficient of absolute and apparent expansion of liquid. Any absolute and apparent. Apparent expansion means gamma L minus gamma C. This we have to find. This directly we can get from here. 1 by 1 minus gamma C by gamma L. 1 by 1 minus gamma C by gamma L, 1 by 7. So this will be your 7 by 6. So correct option your option number 3. Question number 13. When water is heated from 0 degrees Celsius to 10 degrees Celsius, its volume, first option increases, second option decreases, third option first increases and then decreases, and the fourth option first decreases and then increases. See, as we know, water has peculiar property. Normally, on heating, volume of a substance is increases and density or decreases. But in case of water, what has been found, from 0 to 4 degrees Celsius, its density or increases, and after 4 degrees Celsius, its density or decreases. So if density or increases first from 0 to 4 degrees Celsius, so volume your decreases, and after that volume your increases. So correct option your first volume your decreases from 0 to 4 degrees Celsius, then further from 4 to 10 degrees Celsius volume your increases. So correct option your option number 4. The fourth is the correct option. The question number 14, it is assertion region based question here. Assertion given, a vessel is filled with water up to brim at 4 degrees Celsius. It overflows when the system is cooled or heated. Region, water has minimum volume at 4 degrees Celsius. So in the first option, if both A and R are true, or R is the correct explanation of A. Second, both A and R are true and R is not the correct explanation of A. And third, A is true but R is false. And the fourth, R is true but A is false. Now see how to do this one. This is a similar type of problem which we have discussed earlier. As water has peculiar property, its density is maximum at 4 degrees Celsius. So when density is maximum at 4 degrees Celsius, the further temperature increases, the density decreases, the volume increases, so it will overflow. Similarly, if further temperature decreases from 4 to 0, then also density of this here decreases, so volume increases, then the water will overflow. In both the case, water will overflow and so assertion A is correct, and it is also correct that water has minimum volume at 4 degrees Celsius because it has maximum density at 4 degrees Celsius. So option number 1 is the correct option, which tells us that both A and R are correct, and R is the correct explanation of A. So hence option number 1 is the correct option.